All right, the final question here, question 3. First of all, what is the resolution of the syringe? Well, what does this word resolution mean? It basically means the smallest measurement you can make. Like, there's a more rigorous definition, smallest measurement. There's a more rigorous definition, which you can look at on the AQA website. But right now, I'd rather just sort of get you the idea. What's the smallest amount you could measure with this? Well, it's actually 1 centimeter cubed, isn't it? And so that's the answer, 1. Now, it's not technically the smallest measurement. It's basically saying how much does the measurement go up by each time. What is the smallest change you can detect? You can detect between 9 and 10, but you can't detect between 9 and 9.5. So the resolution, 1 centimeter cubed. Student compresses the gas. Here is the graph. Okay, what conclusions can we draw? All right, a lot of people here said that, volume goes up, pressure goes down. And yeah, I mean, you're right, but it's not enough at GCSE. We need to do more than that. We need to say, hey, is it proportional? So first of all, is it directly proportional? Is it directly proportional? Well, no, definitely not. Why? Well, directly proportional is a straight line through the origin. Do we have a straight line through the origin? No. So I'm guessing it's probably inversely proportional. And what that means is if one thing doubles, the other thing halves. Now, how do we check that? Well, we should know, and it's on the front of the exam paper, that PV is a constant. And this is an inversely proportional relationship right here. PV equals constant, shows inverse proportionality. So let's test it, right? 200 times 8. So 200 times 8. Can I do that in my head? 200 times 4, 8 is 1600. So this is 1600. I'll ignore the unit for now. Let's choose another one. 10 times 160. Or I suppose we should do 160 times 10. Well, that's 1600 as well. Pressure times volume is a constant. Let's test one more. Is there another nice one to test? Oof, there isn't. Which one shall I test? Can I find one more? That one's not bad, right there. What's that? That's 12.4 times, oh, goodness me, 100 and, oh no, what's this? What is this scale? 140, 20 over 5. Each of these is 4, so 124. That's 128 right there. That's fiddly. 128, oh my goodness. Now, it should be about 1600. It might not be perfect, but it should be pretty close. Let's check. I'm going to use my phone again. 128 times 12.4. Oh, 1,587. So it's pretty close. Yeah, PV is roughly constant. PV is roughly constant. So this shows an pressure is inversely proportional to volume. Another way of writing that, pressure is proportional to 1 divided by volume. If you do Astro, you might appreciate P equals K over V, the constant of proportionality. Last question. Why does the pressure go up as the gas is compressed? Okay, bullet points, please, bullet points. So, compressed means volume decreases. This means frequency of collisions with walls. Let's call it wall collisions. Increases. So the force, pressure, let's say pressure is force over area. So there is more force due to these more collisions per second. So therefore, more pressure. I think that would be a pretty good answer there. When you see the mark scheme, you'll see there's some slight changes, but in general, that's the idea. Volume goes down, frequency of wall collisions goes up, pressure is force over area, there's more force because there's more collisions, and therefore there's more pressure. And that is it. Job done. All right, good job.